Alright, so let's take a look at this video, the Fundamental Theorem of Calculus Part 1. Before I get into it, these are the problems I'm going to be working. I've got 5 of them to work. Alright, so let's get on up here and see what the theorem says. So it says the Fundamental Theorem of Calculus Part 1. If f is continuous on AB, then the function g defined by g of x is equal to the integral a to x of f of t dt, where x is between a and b. It's continuous on the closed interval AB and differentiable on the open interval AB. And then we have g prime of x is equal to f of x. So, not bad. We've got a constant here, and we got our variable x up here. And what we have here is if we have the constant and the variable x here, all we're doing is taking this x and plugging it in for t. So we're replacing t with x. Okay. All right. So let's take a look at our first example. And so you can see we have g of x is equal to the integral 0 to x of the square root of t squared plus 4. All right. So that means we have g prime of x is equal to, so all we're going to do is we've got this x and we're plugging it in for t. Okay, so that's going to give us the square root of x squared plus 4. And there's your answer. Okay, don't worry, they get a little tougher. All right, so let's take a look at the next one. All right, so we've got 1 to e to the x. Okay, so we're going to have g prime of x is equal to, all right, so to work this one, well, what do? Well, we take this, just like another problem, and plug it in right there. Okay, so that's going to give us the natural log of e to the x. Okay, now if you noticed in that first example, well, what did we do? We plugged in x. All right. Well, this is not x. This is e to the x. So we're going to have to use chain rule here. So I plug the function in, e to the x, and then I've got to do times the derivative of this, what I plugged in. We got to do times the derivative of this. All right, so the derivative, well, what's the derivative of e to the x? Well, that's just e to the x. Okay, and we can simplify this some more. Well, what's natural log of e to the x? Well, that's just x, right? Times e to the x. And there's your answer. Okay. Now, I want to go back and say, on this one, we had to multiply by the derivative of this because we weren't just plugging in x. But look, if you go back to this one, you're doing the same thing here too. Okay, we're plugging in the x for t, so that's going to give us the x squared. And then look, times the derivative of this. Okay, so we got times the derivative of x. Well, what's the derivative of x? Well, it's just 1. And so 1 times that is just going to give us the square root of x squared plus 4 back. Okay, so you are doing it, but the square root of x, the derivative of x is just 1. All right, so let's look at the next problem. All right, so let's find the derivative of this one. All right, so if you notice on this one, it's a little bit different in the sense that the constant term isn't the lower limit. Okay, if you notice over here, we've got the constant term, and then we've got the function up here. So we need to get it to look like that again. All right, so what I'm going to do here is I'm going to swap the limits. Okay, all right, so I'm not going to take the derivative just yet. I'm just going to rewrite g of x. So g of x is equal to, and that's going to be 1 to sine x square root of 1 plus t squared dt. Now, remember, when you swap the limits, it changes the sign in front of the integral. So that's going to be a negative. Okay? So it changes it from a positive to a negative. Now, we can apply the theorem. So now I have g prime of x is equal to, now let's go ahead and put our negative, and that's going to be the square root of 1 plus sine squared x, okay, and then times the derivative of sine x, which is cosine x. And this would be your answer. I don't think there's really much more we can do to simplify it. All right, so let's look at this one. All right, so this one's different. This is telling us that we've got limits on both ends. We've got the integral x to x squared. Okay, so let's look at this. Well, that's not going to work, so we're going to have to do something else. Well, if you remember, if we're integrating, okay, if we're integrating and we're integrating from a to b of some function f of x dx, well, if you've got a and you've got b, well, there's some number in between c. Well, we can break this integral up. Like this, okay? So we can split it up. We can integrate from here to here, plus, and then integrate from here to here. So let's do that. All right, so to split that up, all right, so to split it up, I am going to write this as g of x equals, all right, so I'm going to go from x to 0. I'm going to just pick 0, okay, doesn't matter, of e to the t squared dt plus, and then I'm going to go from what, 0 to x squared of e to the t squared dt. All right. Well, if you remember from the previous problem, the constant term has to be on bottom, has to be the bottom limit. So this is going to give me negative 0 to x, because I'm swapping the limits here, e to the t squared dt plus 0 to x squared. Oh, I'm sorry, this right here should be a t squared. I wrote x squared. e to the t squared dt. Okay. All right. So now we're ready to find the derivative. So I'm just going to take the derivative of each one. So I've got g prime of x is equal to, well, that's going to be negative. And so that's going to be e to the x squared. Okay. Well, and then look, I can multiply by the derivative of x. The derivative of x is what? 1. Okay, so that would just give us a 1. Or 1 times e to the x squared. All right, and then plus, and now I'm going to plug the x squared in. So that's e to the x squared squared. Okay, replacing the t with x squared, times the derivative of this. So that's times 2x. And so that's going to give me g prime of x is equal to negative e to the x squared plus 2x e x to the 4th. And this would be your answer. All right, last one. So let's see what we've got. Okay, so once again on this one, we can see that this is going to be the same as the last problem. So let's split it up. And so if I split this up, I'm going to go cosine x to 0. Okay, and that's natural log 1 plus 2t dt plus, and then I'm going to go from 0 to sine x, natural log 1 plus 2t dt. All right. Now I need to swap these limits. So that's going to be negative 0 cosine x natural log 1 plus 2t dt plus 0 to sine x, and that's going to be natural log 1 plus 2t dt. All right, so now we're ready to go ahead and find the derivative. So I've got g prime of x is equal to, well, that's going to be what? Natural log 1 plus 2 cosine x. Okay. So I'm just, all I did here is I took cosine x and I put it in the place of t. And over here, I'm going to take sine x and put it in the place of t. Okay. All right. Now, I plugged the cosine in. Yep. And look what I forgot to do over here. Forgot to bring my negative down. Okay. And now that I plug cosine in, then it's what? It's times the derivative of cosine. Well, what's the derivative of cosine? Well, that's negative sine. Okay. And then I've got plus, and then I'm going to plug sine in. So that's natural log 1 plus 2 sine x, and then times the derivative of sine x, which is cosine x. And so now I guess we maybe, I don't know, not much to clean up, but we can, the negative and negative is positive. Probably be just bring the trig functions out in front of log. You don't have to, but let's just see how that goes. Sine x, natural log 1 plus 2 cosine x plus cosine x, natural log 1 plus 2 sine x. And so that would be your answer right there. Okay, so I know the video ran a little long, but you know, it's covering just about everything you'll come across. So hope you liked it, hope it helped. Give me a like, share, and subscribe, and thanks for watching.